Even though the class, I said, is going to be like 2 hours class for the beginning, we are going to be spending 1 hour, 1.5 hours. Then when you people mature in the class, when we get to the next level, which is NA2, where we're going to be doing configuration, then we may be spending 2 hours or even beyond 2 hours. And at that point in time, I will be giving break, maybe 10 minutes break, and then we'll continue the class. So today I want to continue from where I stopped in our last class. So don't forget, if you have any question, you write them down. When I'm done teaching, I will give room for questions. People can talk, or you can drop your question on the chat during and when I'm done teaching. Not during my teaching. When I'm done teaching, you can drop your question. I am here for you. I'm here to answer all your questions. So feel free to ask questions when the time comes. And I'm also going to try to do a recap of some part of what we did in our last class. I want to connect some things together. I want to connect some dots. And those are some of those things I'm going to talk about when I'm done with some of the slides to drive some points home. Because I was teaching some people yesterday, happens to be the same since anyone, the same topic, and some question came out from that class. And I feel like, what if some people in this class also are having this kind of questions? So I've decided to recap based on some of the questions that came from those guys that I taught yesterday. I believe it will help 1 or 2 people on the platform. So please feel free to ask your question. The reason why you are here is to learn, and I'm here to also teach you. Thank you. So I'm going to talk about, we're going to continue from where we stopped. Don't forget, we are still in chapter 1, which is Introduction to Networks. All of this part, is part of chapter 1. When we move to another chapter, I will tell you guys that I need to do a great job with chapter 1. That's our, what's it called? The part of the foundation. So we are still in chapter 1. So what we want to start with today is network representation and topologies. Network representation and topologies. Class rep, please, in case you people are not hearing me, I will be expecting to see talk from you, even though I believe I should be okay for my hand all through today. Network representation and topology. Now, anytime you hear network representation, what should come to your mind, thank you, is diagram or icons. Network representation in particular, icons. Icons. I'm going to read and then explain some things. Network diagrams, often called topology diagrams. So in other words, when you, yes, I've started recording that. Thank you. Thank you. Network diagrams, often called topology diagram, use symbols. Take note of these, guys. Use symbols to represent devices within the network. So if I am drawing, or I'm drawing what we call a topology. Let's assume now I want to go and network a place, and I am going to use 1 router. I am going to use 10 switches. I'm going to use, let's say, 1 firewall, and I want to put a diagram or a picture of the way all these things will connect together. You're not going to see me giving you physical picture of the equipment. We're going to be using icons. So you need to get familiar with these icons. It's like the architect. Look at the example I gave them in the class yesterday. If a medical doctor prescribed drugs, wrote some things on paper, you that has no idea about medicine or medical stuff, you won't be able to interpret that. If an architect should design something, if you are not conversant with their terms, with their terminologies, you won't be able to interpret it. We have similar stuff in our field. This is part of our own way of, permit me to use it, speaking in tongue, speaking mysteries that others that are not in networking don't understand. So now, in our last class, I talked about router, I talked about switch, I talked about multi-layer switch, I talked about firewall, I talked about what one again, bridge, I talked about hub. All of these devices, remember, I call them intermediary devices. All of these intermediary devices, they have icons to represent them. Take, for instance, look at the way we represent a switch. Look at the icon for a switch. Look at the icon for a router. So if I should draw something like this, what it simply means, I have one router and that router is connected to a switch. That is the meaning of that my drawing. What if I put something like this again? That means I added another switch. What if I put something like this again? That means I had another switch. So it means in this my drawing right now, we don't call it drawing, we call it diagram, or we call it topology diagram or network diagram. There is one router and there are 3 switches. What if I now had something called a firewall in between? Look at the icon for a firewall here. So you should be able to interpret and say there is one router, one firewall, and then of course 3 switches. So we use all these icons. Class rep, can you see my screen? If you can see my screen, you can give me thumbs up. Somebody is saying you cannot see my diagram. Okay, it should be from your own hand if you can't see my screen. Thank you. I can see your thumbs up. So this thing I'm drawing on the screen, who is raising up hand? I say no question within when we're in class until when we are done. No question. Somebody is raising up hand. Were you not there when we set the rules and regulation? When I'm done, you can ask question. Then I will answer all the questions. I cannot be stopping in between and be answering people's questions. That's what we did in our last class. So what I'm trying to say, guys, is this. We use these icons to represent the devices. I am talking about intermediary devices right now. So take note, take a look at all the icons we have on the screen. When we see a wireless router, look at the icon for a wireless router. When I'm talking about the switch, look at the icon for a switch. When I'm talking about a router, look at the icon for a router. When I'm talking about firewall, look at the icon for a firewall. And when we're talking about another type of switch, which we call multi-layer switch, it is a switch that can do the job of a router and also work as a switch. Look at the icon for that multi-layer switch. You need to get familiar with all of these icons or symbols to represent all these intermediary devices. You're going to see a diagram when we move to another slide right now, and you should be able to interpret that diagram. That is one part. Another part is our network media. You remember we talked about media in our last class. When you are using a wireless connection, look at the icon to represent wireless connection. When you are using physical cable that connects to local area network, look at the icon to represent it. And when you are connecting to what we call wide area network, look at the icon to connect to wide area network. Now, some of you may not understand what I mean by LAN on WAN. I'm going to get there into this class. It's part of what I'm going to take care of into this class. So you're going to see. So when I am connecting my computer to a switch, this is my PC, and this is my switch. When I'm connecting my computer to a switch, the cable I'm going to use, this is the icon. You see the icon here? That means I am using a LAN media or a LAN cable. And that is when you are talking about media, network media. This is when you are talking about intermediary devices. The good news for end devices is they look alike or they look the same. Case in point, look at the icon for a desktop. It looks like a normal desktop. Look at the icon for laptop. It looks like a normal laptop. Look at the icon for a printer. It looks like a printer. Look at the icon for IP phone. It's the same thing like the IP phone. Tablet is tablet. Telepresence endpoint is telepresence endpoint. So the icon look exactly like the written for end devices, but it's not the same for intermediary devices. As a matter of fact, let me show you guys something. Let me go to Google and show you guys something on Google. Let me Google Cisco switch. Cisco switch. So you see the Cisco switch now. Look at Cisco switches here. All these switches you are looking at here, they are Cisco switches. This big one you're looking at here. This switch you are looking at on my screen right now. and the icon I gave to you, they don't look alike. That's what I'm trying to tell you. What if I brought out a router? Let me bring out Cisco router. Let me show you the image of a Cisco router. Router, where are you? Router. This is a router here. So if you take a look at this icon now, this is a router here now. This is a router. This is a Cisco router. It doesn't look like the icon does not look like the real thing I gave you. So that is the point we're making. We speak in another language when we are telling you, or when we are designing, when we are trying to show you the devices on our network, we use icons to represent those devices. And this is a standard practice. This is a known thing all over the world. So you need to be aware of this. Let me now read this. Network diagrams, often called topology diagram, use symbols to represent devices within the network. So we're going to look at one of the network diagrams right now. And there are important terms to know. For instance, in our last class, I talked about network interface card. It's the same thing as your physical port. We call it also the interface. So when you have a computer right now, and you have a port where you can plug your cable, your computer to the network, this port here is called a network interface card. It's a physical port. It's an interface. That is what enables your computer to interface with the network. So we're saying the same thing. So sometimes we use all of these things interchangeably. It's another important term. I mentioned that in our last class. So stay talking about this network diagram of a thing. Look at my next slide. If I told you now to interpret this place for me, this topology for me right now, or this diagram, you should be able to interpret it. How do we interpret it? In this organization, this probably belongs to an organization now. They have one router. They have 1, 2, 3, 4, 5 switches. They have one printer. And they have, these are servers. These icons are servers. There are 3 servers. And of course, look at the icons for computer. 1, 2, 3, 4. 3 laptops, 1 desktop. So if you just got a job in an organization like this, for instance, and you have no idea what is on ground, you request for the topology diagram because you need to know what they have and the location of those devices. It is from there, you know, in this organization, they have one router, they have such a number of switches, they have such a number of router, such a number of, every organization must have that. If you build a network, you must have this kind of diagram for that organization. It's like map for the house or for a building. If there is war and they want to go and attack a city or a building, all they need is just the map. Even if you have never been there, once you take a look at the map, you know all the connections of the roads. You know how many buildings are there. Even you can even go down to a particular building and say, okay, in this building, there are 12 rooms, so number of toilets, so number of rooms, so number of these, and so on and so forth. We have the same thing when we build a network. We must have our diagram. And in our diagram, all our devices, intermediary in particular, are represented with icons that you need to be familiar with. But if you take a look at this diagram here, this one on the left and this one on the right, there are some things that are different there. Even though they have the same number of devices, same number of computers, everything, same, except few things are different. There are some things that are on the right that are not on the left. There are some things that are on the left that are not on the right. So what's the difference between the two? The one on the left here is referred to as physical topology diagram. Physical topology diagram. This one just illustrates the physical location of intermediary devices and cable installation, where they are located. We have had a situation in the place where I work where they will call that they cannot browse in a particular department, and the person that will be sent there will be looking for where the switch is for that particular building. And nobody, if you don't meet somebody that really know where the device is, everybody will just be turning, we don't have any device here, or we don't know where the device is. All the person needed to have done is just to take a look at the diagram from our server room to that department. And in that department, where did they drop the switch that took internet connection to that department? Case closed. Room what? Then you'll be able to know. Then you go straight and go and check what is going on with the switch. And if you take a look at this topology diagram, it has the rack number. I believe you should know what a rack is. That is where we mount all our devices. Shelf number, rack number, shelf number, rack number, shelf number. Okay, even the computers have rooms where they are located. The servers too, they have room where the servers are located. All of these details must be captured under our physical topology diagram. But we have to go beyond that. We need to go beyond physical topology. We need to also have logical topology diagram. Logical topology diagram will show you further information beyond location, e.g., network addresses. Like, okay, all these servers in this place, which network do they belong to? Now, you may not understand that one now. We're going to come there when we get to IP addressing. Which network? What is the network address of those devices? Okay, this other network here, these other devices here, which network do they belong to? These other devices here, which network? All of these things you are looking at, they are network addresses. They are network addresses. They are network addresses. Now, because we have not done IP version full address, you may not understand all these network addresses of the thing. But when we do IP addressing, you will understand stuff like that. I taught some people in the UK. We had a class this morning and some days ago. I have to put the video on the YouTube channel too, because one of them actually wanted me to be putting it on the YouTube channel. So for people that have enough time and they cannot wait until we get there, you are going to see on that channel where I taught IP version full addresses. I taught IP version 4, part 1, part 2. I just uploaded the part 2 today because we did that this morning. So there are some things that are here. I will just mention them. I cannot go in depth until we get there. IP address is a chapter of its own. So just take note of that. So now the point I'm making is this logical topology will show us the IP addresses of all these devices and the network they belong to, and how we can access these devices, the addresses to use to access these devices. This is not even detailed. It's not detailed. We're supposed to have the IP address on this interface, on this interface, on this interface, the one for the switch, the one for the server. Each of the IP addresses of each of these devices, we're supposed to see them in our logical topology diagram. So that means if you need to access any of the devices, you know the address to use to access the device. So you will always have these diagrams: physical topology diagram, logical topology diagram. Look at what they wrote here under logical topology. Logical topology diagram illustrates devices, ports, and the main thing here, the addressing scheme of the network. The addressing scheme of the network. How you segmented the network and where equipments are placed in each of those segments. These details will be covered under logical topology. And you must have the two for your organization. Any organization, no matter how small they are, you must have these two diagrams. One is physical topology diagram. They are both topology diagrams. The one is physical, the other one is logical. And it's just to represent the devices, how they connect, and the addresses to use to reach those devices. Case closed. That's the combination of the two I just summarized for you there. So don't ever forget this. So if I am going to give you a contract now and tell you to go and execute, you're not going to see me snapping picture of router and switches and put on my diagram. No, I will use the icons and I will connect those things together. You are going to see. So you must be able to interpret, because now I have taught you that you need to use all these icons to know the representation of these devices. So that is that on that. So if you have questions on this part, just write them down. When we finish, we're going to come and answer questions on that. So the next part, we want to go into types of networks. Somebody asked me a question in the last class. That question will be answered, I think, in this section. Common types of network. So don't forget, we have said networks, we have defined what a network is. But we want to take these things further. We want to talk more about different types of networks. These are different terminologies you need to be familiar with. Different terminologies. So in this slide round, you can see, when you talk about network, networks will always be of many sizes, different sizes. If in your house now, let's say I carry my laptop, this is me now, carry my wife's laptop, and this is my wife. We link the two laptops together. This is a network. The two of us are sharing resources. It's a network. If I carry my phone and our phone and use Bluetooth to link the two phones together, it's a network. Different types of network is a network. If I carry tablet and link the two tablets together, it's a network. So the moment you link any of these two devices together for them to share resources, you have created a network. You have created a network. I don't know if I mentioned it in that class. When we talk about, okay, end devices, I think I mentioned it, end devices. End devices, your desktop, your laptop, your tablet, your phone. Somebody asked a question, I think it was an intelligent question. I don't know if it's in this class or those people I taught yesterday, that what about your TV? I say your TV is also an end device if it is a smart TV, not the old school TV. As long as you can connect to the network, it's an end device. Thank you. I'm saying the thumbs up. So when you are feeling the anointing, that you are sending the thumbs up. Thanks. Don't mind me. Oh. Okay. So because the reason why I used to go in depth on some issues, because when I was a student in 2002, I suffered a lot because there were too many things that I didn't understand, and there were there was nobody to explain some of those things to me as a student. Because back then, the people that taught us did not even know the stuff, because they were just trained. They did fire brigade approach training for them and then made them instructors. So nowadays, when I'm teaching my students, all the things that suffered me back then, I try to make sure that I talk about them, in case I have people in my class that are like me when I was a student back then. So any of these devices you connect to the network, as long as you can connect to the network, is an end device. So back to network of many sizes. So the first one you see here is called small home network. What is a small home network? Like if I just connect my wife's laptop to my laptop now, that's an home network. So most of the home network, what they basically do with it is just to connect to the internet. Okay, as I'm talking to you right now, I am connected to my GSM router. I'm going to have to come and talk about GSM router in today's class. My GSM router, I have MTN, I have Airtel. Now, I am connected. Let's say this is my laptop. I am connected to that GSM router through wireless. Now, my wife will also connect to that GSM router through wireless. My sons also will connect to that GSM router through wireless. Can you see that I'm using that icon of wireless? That's like a ring or something like that. Do you know what? All of us are using this router to browse. But let's assume that my data finish and I cannot browse again. All of us can talk together with this router. We can share resources with this router because we have formed just a small home network with this connection. We have built a small home network. We all connected to the router. Just that most of the time, what the people use the router to do is just to browse the internet, but take out internet out of this. All the people that are connected to that router can share resources between themselves. When I say can share resources, if I have something to give to you, you can hit my computer and you get it. I can hit your computer and you get it. That is what we refer to as small home network. Connect few computers together and to the internet using a device. You can use a device to connect these computers together. So what you have done in that case is, in that scenario, you've built a small home network. But beyond that, we have another one called SOHO, guys. SOHO. Small office, home office. For people that work from home. I'm sure you must have been hearing about people that work from home. They don't go to the office. They enter the office in their room and they do everything they're supposed to do as if they're in the office. So they have what we call small office, home office. Small office, home office. Small office, home office. Meaning they log in into the office from the house. Somebody say, is that possible? Yes. When you go to the office, what do? You connect your computer to the office network, and then you'll be able to do all the office stuff. You can also connect from your house using VPN. It's as if you're in the office, your computer will be part of the office. So that office you have in your house that enables you to connect to the office, to your main office or headquarters where you work, is called small office, home office. So it may be you alone, maybe you and somebody. All of you connect to what we call a corporate network. So you don't have to leave the house. That is why nowadays it is very easy for people to work from home. I have one of my friends in Scotland, one of my students actually that I taught, a friend. He works from home. He doesn't go to the office. So they gave him laptop. He would just open the laptop, launch the VPN, and he's in the office. And there is nothing they want him to do that he cannot do from home because he's in the office. The only difference is his laptop is connected to the office. He is at home and he's working from home. So in that kind of environment, that kind of network, we refer to it as small office, home office. And then we have another one called medium to large network, e.g. campus network. When I say campus network, it doesn't mean university. We refer to campus network, any network that is big, maybe 2,000 users, 3,000 users, 5,000 users, we call them campus network. Incidentally, the ones that are very big like that are institutions like universities, polytechnic. Those ones are big network. They are medium net. Some of them are medium net. Some of them are large. By the time you begin to have almost 20,000 users on campus, that's a large network. It's a big network. So that's another one. And of course, your guy at the top, worldwide network. That is our internet. It connects hundreds of millions of computers worldwide, such as the internet. So when you talk about networks, don't let your mind go to your office network. You have a network in your house. The moment you connect to that router and somebody connected to that router, you have a network. The moment you connect your phone to another phone with using Bluetooth or Wi-Fi, you have a network. Just that the networks are in sizes. So you need to understand that. The moment you connect two or more computers together, and when I say computers, I'm talking about any end device that is smart, not just your laptop, not just your desktop. Any end device that is smart, you have created a network. Forget about the internet. Because that's another thing that confused me when I was a student, confused me tired. What is the difference? What is the difference between network and internet? And I remember telling you guys in our last class, internet is just network of networks. So I can decide to have my own network in my house and there is no internet connection and I'm doing my own thing. Sharing resources like some small business centers in those days, they will have, let's say, 6 computers or 10 computers. If it's a big business center, only one printer. And you know what we do? We'll network all those computers together and all of them can print using one printer. Anybody can print because we have shared the printer. We'll first of all build a network for them, then we share the printer. I'm going to talk about that kind of design scenario like that when I'm done with this part of the class. So you need to understand that. I need to move fast. Other terminologies you need to be familiar with. Local area network. Local area network. Now, these things enter themselves. They are intertwined. This thing you are looking at here, this is a local area network. This is a local area network. This is a local area network. So what is the definition of a local area network? Connection of 2 or more computers in an office, set of offices, in a building, set of buildings. This definition I gave you guys now was what was in the curriculum when I was a student. I crammed it in, no really leave my brain. When you say local area network, connection of two or more computers in an office or set of offices, in a building or set of buildings. The only difference is in the size. So if in this office, now I'm in an office and I link two systems together, that's a LAN. More people join that particular LAN. Don't forget, we're going to use a switch. More people join, it's still a LAN. We're just expanding the LAN. What if we now extend that LAN into another building? Maybe we'll drop another switch in another building. We extended that network. It's still a LAN, just that the size is expanding. So in the university where I work, where we have, if I'm not mistaken, over 17,000 users, we have main camp connected to the permanent site. It's still a LAN, just like it's a big LAN. Connections of two or more computers in an office, set of offices, in a building, or set of buildings. That is local area network. Take note of that word, local. Another example I always like to use is the banks. Banks, take for instance, GT Bank. Some of these banks you are talking about, they have like 250 branches. Thank you, OC. 250 branches. So each of the branches may be in different cities. Each of those branches, they are, thank you, Uchi. Each of those branches, they are local area network. When you go to a branch of a bank, it's a local area network. Now, local area network, the branch will be different from another branch because you can get to a branch, they have plenty staff, they have plenty computers. You get to another branch, maybe 10 staff, maybe another branch, 20 computers, another branch. It doesn't matter. It makes no difference. Especially if they have a branch in a village or some remote area, you barely see like 5 people in that branch, but it's still a local area network if they have computers there that they are using for their operation. So those banks will have like 250 local area networks scattered all over the country, or 300 local area networks. Every branch is a local area network. But guess what? By the time we link all those branches together nationwide, that is what now gives you wide area network, because we don't see this bank as separate branches. I'm talking of networking guys now. We see them as one big network. So when all of these branches are connected together nationwide, wherever they are, that is what we refer to as wide area network. Somebody is sending me a tortoise. If I don't see it from the class rep, there is no tortoise. It's from your hand. Class rep, give me a thumbs up if you can hear me very well. If I see tortoise from class rep, I know there's a problem. Okay, and Uche, thank you. Okay, guys, thank you. Thumbs up. So it's from your own hand. So you can restart your data, your network. That may help. So when we now link all those branches together, that is what we refer to as wide area network. So all these banks that you look at now, like GT Bank now, they have wide area network. What do we mean by that? Because all their branches are connected together. But if you want to talk about each of these branches one after the other, each of them in isolation, they are called local area networks, local area network in isolation. But if you refer to all their network as a whole, it's a wide area network. Insurance companies do have this kind of connection too. Big insurance companies that have locations in many cities or many states. They link all their branches together. And these things I'm telling you now, it's old design, new design. Everybody goes to the cloud, because back in those days, the GTB server will be at the headquarters. So you need to go to the headquarters to go and get information about the clients. And that is why in those days, if you go to some of the branches, they cannot attend to you. If you want to withdraw, they will say there is no network. They don't have internet or network to go to the headquarters to access your information, but they can collect money from you and record it locally on paper, so that when there's network, they will now log it in their data, in their server. So they can operate locally, collect money, deposit. But when you want to withdraw, they don't know what you have in your account. They can't give you money because they need to go to the headquarters from wherever they are. So they will now tell you there is no network and they cannot go. So when we say LAN, take note of that. Now, I want to give you a definition of wide area network. I've explained it. Still in the old curriculum, I enjoy that curriculum a lot. When you want to define one, connection of two or more LANs, guys, connection of two or more LANs separated by wide geographical location. One state to another state, 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 to another state. Connection of two or more LANs separated by wide geographical location. That is what we call wide area network. Connection of two or more LANs separated by wide geographical location. So you need to be aware of all of these terminologies. So when you build a network, you need to know what is a LAN, you need to know what is a WAN. Another one I want to talk about, I didn't see it in this curriculum, I don't know what happened, is MAN, Metropolitan Area Network. Metropolitan Area Network. I still like to go back to these banks again. Some banks in a city, we have main branch and other branches in the same city. And those branches will be connected to the main branch. That will create what we call Metropolitan Area Network. It's a metropoly. If you want to take care of, or you want to refer to that network that was created in isolation, the branches of the bank in that city connecting to the main branch gives you Metropolitan Area Network. So when we say LAN, you should understand what we're talking about. When we say MAN, we should understand what we're talking about. When we say WAN, you should understand what we're talking about. Unfortunately, there is no woman in our terminology. I hope the women in the house will forgive me before they will shut down the class. Class rep, I hope I'm not looking for trouble. So we have MAN, we have LAN, we have WAN, guys. There's another one I didn't see here. I think I remember where I saw that when I was teaching CompTIA A+. That is IT Essential. PAN. That is PAN. I think it's Private Area Network. When you use Bluetooth to link your phones together, you just created Private Area Network, PAN. When you use Bluetooth, because you can use Bluetooth to connect multiple phones together. You can use Bluetooth to connect laptops together. You can use Bluetooth to connect tablets together. Tablet to laptop, laptop to tablet, tablet to phone, anything to anything, as long as they have Bluetooth. So you create what they call, because the distance that thing can cover is not long, it's not far. That's why they call it Private Area Network. There's also CAN too. I can't remember the full meaning of CAN. That somebody just wrote down for me. So we are going to restrict our discussion on this. LAN, MAN, WAN, and then the last one is PAN. So take note of that. So don't forget, LAN, I've explained it to you. When you connect two or more computers together, it now depends on the size of the LAN, the numbers of users, and the type of services available, and of course, area of responsibility. Don't ever forget that. And this is what they are trying to show to you here again. This is a LAN here. This is a LAN here. Branch 1, branch 2, okay, campus area network. I'm not going to go into that. So now when you link all those branches together, it gives us what is called a wide area network. That is the connection of two or more LANs that spans a wide geographical location. Now there are, let me say, advantages, or let me say controls you have over the LAN, and you lose those controls. What do I mean by that? When you build local area network, you control the speed, what we call bandwidth. I'm going to talk more about that in another class. But when you are in the WAN, you don't control the speed because you are paying heavily for the speed. So that is why sometimes one connection may be slow. Why? Because it's expensive. You use the service of people like, let's say, MTN. I think in Nigeria, the main carrier in Nigeria is Glo. They are the main carrier. They can give us one connection, and I'm not talking internet. Like all these banks that I talked about, they're connecting themselves together. They use the service of people like Glo or people that have fiber connection nationwide to link themselves together, and they pay them monthly or yearly for that service. So that's why sometimes you hear the bank will tell you there is no network, because the main link they are using is done and they don't have backup. So they don't have control over that one connection. They can only pay or rent that service. But when you build a local area network, you are fully in charge. You control the speed. You decide on the kind of bandwidth to have in that your local area network. And all of these things, we're still going to come to those ones later, much later. And of course, the guy at the top again. I call the internet the guy at the top. It's a worldwide collection of lands and WANs all over the world. It's a network of networks. LANs are connected everywhere using wide area technology. The whole of CCNA3 is talking about wide area technology. And some of these connections may be through wire, maybe through fiber, maybe through copper wire. It makes no difference. Media is not our problem. The type of media used is not our problem, as long as we can connect. Wired or wireless, physically or spiritually, makes no difference. We can connect anywhere in the world. So these are the types of network you need to understand. You need to know them very well. I'm going somewhere. I was going to give room for question. Now, there are bodies that maintain the internet. They are like, you have like IETF, ICANN, and I. These are people that manage this internet stuff. When I say manage, when it comes to allocation of IP addresses, the next thing to be done, moving to IP version 6, all kinds of stuff, they manage all of this. We're still going to come to some of these things. So somebody asked me a question about this in our last class. So I pray the person is listening, and the person should listen attentively. This is another thing we need to discuss under the types of network. Thank you, guys. Intranet and extranet. What is intranet? What do you mean by intranet? And what do you mean by extranet? I'm going somewhere. Let me get a blank sheet or go to my board. I need to show you guys something. What do I mean by intranet? Let's build a local area network. This is a switch. This is me. This is class rep. This is Uchi. Is it Uchi or Toche? And this is who else is there I can remember? Okay, blessing. Some people are very fast. Pass me not gentle savior. So all of us are connected together through this switch. Of course, you guys know that this is a local area network. But you know what, guys? What if we want to send mail between ourselves? We want to send mail to ourselves or between ourselves on this network. Now, when I connect all these computers to the switch, now that doesn't mean we're all sitting down on the switch. That's not the way it works. The switch could be in the server room. Please, can you stop typing questions now? I said I will give room for questions. You are distracting me. I will give room for questions when we are done. We've said this before. This is the rule in the class. I will give room for questions. So let's say we are all seated, we are all connected to this switch. Now, in the real world, the switch will be in the server room. You may be in your office. I'm in my office. Another person is in another office. But you can even be in a different building. It makes no difference. And then we want to send email to ourselves. How can we send email to ourselves? We need email service. Which email service do we need? Do you want Gmail? Or you want Yahoo? Or any other email service provider? So if we need Gmail or Yahoo, that means we need internet connection on this network. But if we don't want internet connection, we want to do our own thing our own way. You know what we can do? We can have a server called email server. We build it ourselves, set it up, create email addresses for everybody. We used to have something like that in the university, where our email server was resident in our local area network. With that, we do not need internet connection to go to check mail. There was a time our website was resident in the university. Our website, which we call a web server, was sitting down with us in the university. We do not need internet connection to access our web server. It is the people from the outside that need internet connection to reach that server, because the server is not on the internet, it's with us locally. So now, what if we want to be chatting on our network, or we want to have a social media platform? We can create our own, let's call it Backbook, not Facebook now, www.backbook.com. That's our social media website or server. Stay plugged to this switch, guys. If all of these things I'm talking about, we don't need internet to chat with ourselves. All we need is create an account, log into this server, create an account for yourself, just the way you do with Instagram, the way you use WhatsApp, the way you do with Facebook. And guess what? All of us in this organization, in the university, can chat with ourselves. We can send mail to ourselves. We can check our website. This is the point I'm making. When you begin to use internet applications locally, another way to refer to that, your organization or what you have built, is to call it intranet. It is not an internet. It is a local area network, no doubt. But because you are using internet applications locally, we refer to that as intranet. You don't need internet connection to go and do any of these things I've talked about. So you have your own internet. It's like you built your own internet in your own environment. You don't need internet connection. You don't need to go out. Everything is resident with you locally. We refer to that as intranet. Somebody asked this question in the last class. I said I will answer that in today's class. Now let's assume this network that I've just built now, this intranet, belongs to let's say University of Jos. It belongs to University of Jos. Then there is another intranet that belongs to, let's say, UNILAG, University of Lagos. They also have their own intranet. So now this is the point. If UniJos intranet want to talk about UNILAG intranet, they are extranet. It's like external network. To University of Jos intranet, UNILAG is extranet outside. But when you go to UNILAG, the people in UNILAG will be seeing UniJos network as extranet because it is external to them. It's not their own. So what if they have things to do together? They refer to UJ as extranet. UJ refer to them as extranet. But when they are talking about somebody just, I don't know, try to annotate again. When they are talking about their network locally, can you people still hear me? Class rep, thumbs up. When they are talking about their network locally, they call it intranet. Thank you. They call it intranet. So that is the point I am trying to make there. Intranet and extranet. When you use internet application locally, what you have created is called an intranet. Intranet. See, I have talked and talked and talked about questions. Somebody is still raising hands now. So don't forget that, guys. So when you talk about intranet, locally to you, but majorly because you are using internet application. When you talk about extranet, that's outside, other people outside doing the same thing you are doing. And of course, we know about internet, World Wide Web. All of us know about that. Don't ever forget this, guys. Don't ever forget this. This is key. This is very important to you. So all of this terminology, you need to know them like you know yourself. I tell my students, when you're talking, when I'm done with you, you should not be doing maybe. There's no guesswork. You should talk convincingly because you know what you are talking about. So that is that on that. So let me quickly do a recap of some things about our last class, then I'll give room for questions. So now, how do you build a local area network? If you drop a switch, don't forget a switch is to aggregate connection, wired. So this is computer. You connect it to the switch. Let's say Roland. Then let's say this is the class rep connected to the switch. And then we have a local area network. Don't forget, 2 or more computers, local area network. Now, what if Uche comes? Uche bought a laptop without a network card. I'm talking of the one with wired. How can we connect Uche to this our network that we are building? It's very simple. We go and get an access point. Remember, I talked about access point in our last class. Access point is a wireless device that gives you wireless signal. And most of you must have seen access point. If you have not seen it before, when you enter in an environment and you see wireless signal and you click it and you connect to it with or without a password, that's an access point giving that signal. We connect that access point to our switch. Uche connects to the access point wirelessly. And guess what? We are on the switch wired. Uche joined us wirelessly through the access point. So we have built both wired and wireless network. What if another person comes? Here comes Blessing. She also bought a system without a network card. When I say without a network card, without wired network card. So she has wireless. She can also connect to the access point. So they are joining using the wireless network to connect to the wire. How? Because there is a connection between this AP and this switch, a port on the switch. So whether you join through wire or you join through wireless, we are members of the same family. All of us can talk to ourselves. Roland can send message to Uchi. Class rep can send message to Blessing. Even though they are connected to wireless, it makes no difference. It makes no difference. Then somebody asked me a question. This was yesterday's class. So how would these people, how would they browse the internet? I said, that one is not a problem now. All we need to do is to go and meet a service provider, an ISP, get internet connection from them. A cable is coming from them. Most of the time, the cable goes to the router, and then there's a connection from the router to the switch. Bam! The internet connection has entered this router. From the router to the switch, everybody begins to browse. Now, what I need you to understand is this. Browsing is the secondary thing, even though it's the main thing to us now. But even we don't have this connection, you people can talk to yourself in this organization. You can share resources. We can put a printer here right now and share this printer, and anybody, that is a network printer now, for instance, anybody on this network can print. But because we cannot do without the internet, that is why we are connecting the service provider, get internet connection from the service provider. It goes to this router, and then since the internet has entered the router, we inject it into the switch. As long as internet connection entered this switch, guess what? The people that are on wired, Roland, class rep, they can browse. The people that are on wireless, they can browse. So whether wired or wired, as long as there is internet in this switch, everybody can use this switch to browse the internet. Now I said that something in that class. This router is a dedicated router. When I mean dedicated, it's only a router. This switch is only a switch. Access point is only an access point to your GSM router that people use in houses. For organization, this is the design. But when you want to that house, it's a small environment. You don't need this kind of dedicated devices. They will be too expensive for you. That is why people came up with GSM router. They came up with GSM router, and guess what they did with GSM router? When you buy a GSM router, guys, you know how that GSM router will come with a port. For those of you that have seen GSM router before, most of the time 4 ports. They do some with only 1 port. This GSM router. Now, I can connect all my computers to this port here. Forget about internet now. This is me. This is class rep. This is Blessing. This is Uchi. We just power this, our GSM router, and connected to those ports. Do you know what? I've created a local area network through wire. All of us can share resources between ourselves. Forget about the internet. And this is what makes this GSM router a switch. Now, what if we have other people, they don't have network card to connect, or we have exhausted all the port on this switch? This GSM router that you people know is also an access point. It can give wireless signal. So people will connect to this thing wirelessly. They will connect to the access point wirelessly. So right now, the GSM router is a switch. It's also an access point. People are connecting wired and wirelessly. So what makes this system a router? Because it's giving you internet connection. You can go to the internet and you're able to browse using your SIM card. Of course, you get the internet connection from the service provider, but the reason why it can browse and take you out to the internet is because it's a router. So in other words, this GSM router you people use, you buy from MTN, from Airtel, from Glo, all of these guys all around, it is just an integrated device, integrated. But people just say it's a router. Even those people selling to don't know that it's not just the router. It's an integrated device. It's a router. It's a switch. It's an access point. In fact, guess what? It's also a firewall, because they have some security settings that you can activate that will protect your network or your computers from attack on the network. But most people don't know what to do with it. Only one small device. And the only reason why it is good for home use is because or let me say the reason why you cannot use in an organization, it does not have what it takes when it comes to CPU and RAM to handle heavy traffic. That's why you can't carry it to an office where you have 100 users, 200 users, 300 users, 500 users. That device is just going to look and be looking at people like this, say, honestly, I don't know what to do, or I don't know what I'm doing, because it's going to hang. It doesn't have enough CPU. That's for those of you that know what the CPU is or RAM is. It doesn't know what to do. By the time people try to browse through that device and it's seen the kind of traffic it has never seen in its life, or it's not meant to route, or the traffic that is not meant to enter that thing, it will just freeze because it wasn't made for that kind of environment. So what I'm trying to explain to you guys is this. You need to understand the basics, the rudiments of what you are doing when we're talking about networking, when you were talking about connection. And the one people do a lot. Some even use MiFi. The MiFi will have only one port. That is also good. And when we get to another class, I'm going to tell you teach you what if I want to extend. Okay, we have connected. In fact, let me just do that one here. Let's say now, this my GSM router has just 4 ports. And there are 20 people that want to connect, 20 users, and we don't want them to use wireless. What are we going to do? I can buy a switch and put on this port here. Put some people on this switch. Buy another switch, put on the second port, put some people here. Buy another switch, put on this or put some people here. Buy another switch, put on this port, put some people here. I have extended the network. So everybody here will be using through this port. All the people I've extended. All the people on this switch will be using this one. All the people on this will be using the other one. So I can accommodate. Most of the time when you go and buy those routers, they will tell you that you can connect 30 users wirelessly or wired. So if I don't want wired, then call like those CBT centers that are doing CBT. Let's say now they want to connect people wired by force by fire, and this router only has 4 ports. You can extend. You can extend. So all these users that are on this switch, they will be able to browse, if that's your intention, through this router. These are all the possibilities you should know that are available out there. Now, when I teach some of these basic stuff, it is more, if you understand, it is more enough for you to go and get some small contracts for some organization that have 10 users, 20 users, 10 users, 20 users, just to give them internet connection. So now I'll give room for question.